Hello students, welcome back to the 7th video of this playlist. So in this video we will be solving question number 7 of June 2024 P4 paper. So let's see the question. So basically question number 7, it's from the main topic of this question is differential equations. So basically differential equations is a part of integration of A2 pure mathematics that is discussed in chapter number 6 of your P4 book. So the concepts behind this question is basically will be found in chapter number 6 of your P4 book. Okay, so let's get started with question number 7. Okay, so in question number 7, the current X amps at time t seconds after a switch is closed in a particular electric circuit is modeled by the equation dx over dt equals to k minus 3x. So the equation that is used to model the current in a circuit t seconds after it has been closed, it is given by this equation. Okay, where k is a constant. Initially there is zero current in the circuit. That means when when t equals to 0, when t equals to 0, current is how much? The x, it represents the current, so x equals to what? 0. Initially there is no current in the circuit. Okay, solve the differential equation. In part A they asked solve the differential equation to find an equation in terms of k for the current in the circuit at time t seconds. Give your answer in the form x equals to f of t. Okay, so we have to solve this differential equation. So let's see for part A. So the equation is given as dx over dt over k minus equals to k minus 3x. So dx over dt equals to what? Dx over dt equals to k minus what? 3x. Okay, so let's see. The concept of differential equation is that the first thing we need to do is that we need to take all the terms with x on one side and all the terms with t on the other side. So here we can see that there are no terms with t, but there are constants, right? So basically what we will do, we will take the terms with what that has x in it on left side, and the terms which has t, we will take them on the right side. So let's do this. So dx, there is dx, so k minus 3x, because we will take the k minus 3x, the whole equation on the left, because it's in summation, so it's not possible to make it separate. So that would be what? 1 over k minus 3x equals to what? 3x. Dx would be equals to what? Dt, right? Fine. Now what we need to do, the second step is to what? Integrate both sides at the same time. So we will integrate both sides. 1 over what? K minus what? 3x dx equals to what? Integration of 1 dt. Since there is nothing there, you can consider 1, because 1 times anything is 1. Okay, so now if you integrate both sides, what you will be getting? 1 over k minus 3x. Integration of 1 over x is ln x. That means the integration of 1 over k minus 3x would be what? Ln k minus what? 3x, right? Modulus. Okay, so why we are giving modulus there? Because we know that domain of logarithm cannot be negative. Okay, so now it is what? Reverse chain rule. For reverse chain rule, what we need to do? We need to differentiate. After integrating, we need to differentiate the part within the bracket or the modulus. Here it is modulus. So if you differentiate the part within the modulus, what you will get? Negative 3. And then you will use the derivative of the part within the modulus to divide the coefficient of this term. So the coefficient of this term was only 1. So that should be what? 1 over negative That's it. So then on the other side, what you will say? Integration of 1 is what? We are integrating with respect to d, with respect to t. So in that case, integration of 1 would be what? T. T plus c. Yeah, that's it. We have to add c. So c is an arbitrary constant. That means it is basically considering all the constants after adding them up. Okay, so if you write c here, you don't need to add any c on that side, because this is an arbitrary constant. Okay, now what we need to do, we need to multiply both sides by -3. Okay, so what you will get? ln k minus what? 3x modulus equals to what? Since you are multiplying by -3, it will be -3t and plus what? 3c. No, it will be as it is, just c, because this is an arbitrary constant. It is the simplified constant. Okay, so now we need to substitute what? We know that initially they said what? When t was 0, x was 0, right? When t was 0, x was what? X was also 0. So we'll use this fact. So if t is 0, then x is 0, then what would be the case? C would be equals to what? ln what? ln just k. Okay, so what we can write now? We can write ln k minus 3x ln k minus 3x, okay, modulus equals to -3t, and c is what? Plus ln what? K, right? Okay, now what we have to do, we can take ln k minus 3x right there. So we need to make x subject from there. So take ln k on the left side. Okay, take ln k on the left side. So if you take ln k on the left side, what you will get? Here it is k minus 3x. Here you can see k, ln k. So ln same. So since they will be in subtraction, so use the laws of logarithm. Using the laws of logarithm, we can write k minus 3x over what? K whole modulus. Okay, equals to what? -3t. Okay, now we will convert this logarithmic equation to exponential. So that would give you what? That would give you what? K minus 3x over k equals to what? Equals to e to the power -3t, using the laws of logarithm. Okay, now cross multiply both sides. So what you will get? If you cross multiply, what you will get there? Okay, if you cross multiply, you will get k minus 3x, k minus 3x, k minus 3x equals to what? K e to the power what? K minus 3x equals to k minus 3x equals to k e to the power -3t. Negative what? 3t. Fine. Now we need to make subject x from there. So take 3x to the right side, it will become positive. Then take k e to the power -3 to the left side, it will become -k e to the power what? -3t. Fair enough. Now just make x the subject. So if you make x the subject, what you will get? You will get you can take k common from there. So that would be k over 3 times 1 minus what? 1 minus e inverse what? 3t. And that's the equation that wanted by the question. X equals to f of t. Fine. Okay, that's it. That's the answer for part A. Next, part B. Given that in the long term the current in the circuit approaches 7 amps. In the long term, what does it mean? In the long term means that t tends to infinite. That means t is what? Longer term means what? It's a longer value. It's a longer time. That means time will be infinite. So as t tends to infinity, we need to use some concepts from limits here. Okay, so if t tends to infinity, you will see that e inverse 3t. Okay, if t for long term, t will tends to what? Infinite, right? So e inverse 3t will get what? Equal to 0. Okay, so you'll get x. That means if it becomes 0, then you will have, so what you can write? So k over 3 would be what? K over 3 equals to what? 7, because they said x would be 7. So that means the value for k would be what? 21. K would be what? 21. That's the value for k. Okay. Next, part B. Part C. Hence, that means we need to use the answer from the previous part B and also part A. Find the time in seconds it takes for the current to reach 5 amperes. Okay, 5 amps giving your answer to two significant figures. Pretty simple. Okay, we will just need to use the equation that we have derived in part A, and besides that we will be also using the value of what? K. So we got what? X equals to 21 over 3. Basically it is what? 7. 21 over 3 is 7 times 1 minus e inverse what? 3t. This is the equation. Now they asked to find the time, right, to reach 5 amps. So x would be what? X would be 5. So if x equals to 5, then what we can write? 1 minus e inverse 3t equals to what we can write? 5 over 7. 5 over 7. Okay. Now take e inverse 3t to the right side. E inverse 3t, it would be what? 1 minus 5 over 7. What is this? 1 minus 5 over 7 is 2 over 7, definitely. So 2 over 7. Now you can take ln on both sides. If you take ln e is what? 1. So you'll get negative 3t equals to ln 2 over what? 7. 2 over 7. Okay, fair enough. Next, just you make the t the subject and find out the possible value for what? Find out the value for ln 2 over 7. Find out the value for t. Okay, so ln 2 over 7 is negative 1 point something. Divide negative 3, it would give you 0.4175 something. Okay, so you can round it to what? We can round it to, we can round it to how many significant figures they wanted? 2 significant figures, right? They wanted up to 2 significant figures, exactly. So up to 2 significant figures, what it would be? 0.42 second. And that's basically the answer to part C, and that's the end to the question number 7 of June 2024 P4 paper. Fine.